Okay, good day. This is Trigonometry video number 4-B in continuation to the lesson on using the definitions of the trigonometric functions. So let's have some exercises in application to the said lesson. Okay, first set of exercises. Use the appropriate reciprocal identity to find each function value. Number 1, find secant theta given that cosine theta is 2/3. We all know that secant theta is the reciprocal of cosine theta. So for you to find secant theta, you simply need to find the reciprocal of cosine theta in the given, which is 2/3. The reciprocal of 2/3 is 3/2 or 3/2. Hence, if cosine theta is 2/3, then secant theta is 3/2. As simple as that. Number 2. Find cosecant theta given that sin theta is -3/7. Okay. Find cosecant theta given that sin theta is -3/7. So, cosecant theta is the reciprocal of sin theta. Hence, cosecant theta would be -7/3. And finally, find cotangent theta given that tangent theta is 5. The reciprocal of 5 is 1/5. Therefore, cotangent theta is 1/5. Okay. That's very easy. Let's go to the next set of exercises. Okay, number 1. You are to find cosine theta given that sin theta is 3/5 and theta is in quadrant 2. Again, find cosine theta given that sin theta is 3/5 and theta is in quadrant 2. So, there's this parameter apart from sin theta, which is 3/5, we are given with a condition that the angle is in quadrant 2. Meaning to say, the angle which is in standard position, vertex is at the origin, initial side is at the positive x-axis, that's non-negotiable. The terminal side of that angle is found in quadrant 2. Okay? Again, the terminal side of that angle is found in quadrant 2. Okay. So that's one thing that you have to put in mind. So how do we do this one? Solution for number 1. You rewrite the given. Sin theta is 3/5. The definition of sin theta is y/r. Meaning to say, since sin theta is y/r, it follows that y is equal to 3 and r is equal to 5. And since x squared plus y squared is equal to r squared, x squared plus 9 is equal to 25. The square of 3 and the square of 5 would be 9 and 25 respectively. X squared is equal to 16. If you are to take the square root in both sides of the equation, you would have x is equal to positive and negative 4. Okay. The question then, which of the two values of x you are going to take for you to eventually find cosine theta? Okay. Take note that there is this parameter that the angle theta is in quadrant 2. If an angle theta is in quadrant 2, its x-coordinate, the x-coordinate, how do I say this? The angle is in quadrant 2. The terminal side of that angle is in quadrant 2. Di ba? You pick a point which is found on the terminal side. That point has coordinates, abscissa and ordinate, x-coordinate and y-coordinate respectively. The x-coordinate or the abscissa of a point which is found in quadrant 2 is negative. Di ba? Again, the x-coordinate or the abscissa of a point which is found in quadrant 2 is negative, while the y-coordinate or the ordinate of a point found in quadrant 2 is positive. So, going back, since x is equal to positive and negative 4, we should take x to be equal to negative 4 since theta is in quadrant 2. The terminal side of theta is in quadrant 2, and if you pick a point, any point found in the terminal side of that angle found in quadrant 2, the x-coordinate or the abscissa of that point must be negative. Hence, we discard positive 4, we take negative 4 as the value of x. I guess you are thinking that the positive square root is the principal square root, which should be given the somehow the priority because it is usually the one being used most of the time, correct? Pero you have to take note that it is specified that the angle must be found in, or the angle is found in quadrant 2. Hence, in quadrant 2, the x-coordinate or the abscissa must be negative. So, x is equal to negative 4. After finding x is equal to negative 4, since cosine theta is defined as x over r, therefore, cosine theta is negative 4 over 5. This is the answer. Okay, number 2. Let's go to number 2. Number 2. Wait. Let me show another way of doing number 1. Since it is specified that you have to use identities to solve each of the following. Okay, number 1. You are to find cosine theta and then you are given with sine theta. Which of the trigonometric identities would be applicable if you are given with sine theta and then you are to find cosine theta? So, you must be using the Pythagorean identity, which states that sine squared theta plus cosine squared theta is equal to 1. That's a Pythagorean identity. Correct? Okay. Then, you would have since sine theta is 3 over 5, the square of sine theta would be 9 over 25. Cosine squared theta will just be copied, is equal to 1. Subtract 9 over 25 to both sides of the equation. Therefore, cosine squared theta is equal to 25 over 25 minus 9 over 25. 25 over 25 is the fraction that would be replaced with 1. so that it will have the same denominator with negative 9 over 25. Therefore, cosine squared theta is 16 over 25. Taking the square root in both sides of the equation, therefore, cosine theta would be positive or negative 4 over 5. But between the two values for cosine theta, which is either positive or negative 4 over 5, we take, of course, the negative value. Cosine theta must be negative 4 over 5. Actually, cosine in quadrant 2 is negative, which I will be explaining in a separate video later on. Okay. So, cosine theta is negative 4 over 5. Okay. Number 2. Let's have number 2. We will just rewrite the given. You are given with cotangent theta, which is negative 1/2. Okay. Cotangent theta is negative 1/2. Theta is in quadrant 4. Okay. Cotangent theta is negative 1/2, while theta is in quadrant 4. Your objective is to find cosecant theta. Find cosecant theta. Okay. How do we do that? Solution. Ask yourself, what is the definition of cotangent theta? Cotangent theta is defined as x over y. Again, cotangent theta is x over y. Take note that in the given cotangent theta, which is negative 1/2, the negative sign is neither placed in the numerator nor in the denominator. Diba? We have always emphasized before that the negative sign in a fraction may be placed anywhere. It may be placed in the numerator, in the denominator, or even before the fraction is written. Like in this case, negative 1/2. It is not placed in the numerator, it is not placed in the denominator, but it is placed before the fraction is written. But regardless whether you place the negative sign anywhere in the numerator, in the denominator, or before the fraction is written, the value will be the same, negative 0.5. Correct? In the same manner that when you divide negative 8 by 4, you get negative 2. When you divide 8 by negative 4, you still get negative 2. The placement of the negative sign in a fraction does not really alter or change the value of the number. However, it is important that in this particular case, you need to determine whether it is the numerator or it is a denominator which is the negative value. Why? It's because this is trigonometry, and there is this parameter that the angle which is in standard position, vertex is at the origin, initial side is at the positive x-axis, the angle theta, which is in standard position, is found in quadrant 4. And in quadrant 4, going back to our lesson in intermediate algebra, for a point to be found in quadrant 4, its abscissa or its x-coordinate must be positive, while its y-coordinate or ordinate must be negative. Diba? Again, for a point to be found in quadrant 4, for a point xy, for an ordered pair to be found in quadrant 4, its abscissa must be positive, its ordinate must be negative. Hence, cotangent theta, which is negative 1/2, is actually equal to 1 over negative 2. It should not be equal to negative 1 over 2. It should not be equal to it should not be equal to negative 1 over 2. Rather, it is equal to 1 over negative 2. Because in quadrant 4, to where you find the angle theta, drawn in standard position, in quadrant 4, the abscissa is positive while the ordinate is negative. Therefore, x must be positive and y must be negative. So for emphasis, let me rewrite it. X is equal to 1, y is equal to negative 2. Do you follow? Okay. Again, regardless of the placement of the negative sign, the value of the number does not change. But you have to ascertain between the numerator and the denominator which is the negative number. In this case, we have established that the denominator is at the the denominator is the negative number, since y, which is a denominator, the y coordinate or the ordinate in quadrant 4 is negative. Okay. You're now what's next is for you to solve for r. So since r is the square root of the sum of x squared and y squared, so r is equal to square root of 5. There's no question whether r is positive or negative, since r is always positive. R should be always positive because r is a distance from the point in the terminal side to the origin. There's no such thing as negative value for r, since r is the distance from the point found on the terminal side of angle theta to the origin. So, since what you're looking for is cosecant theta, and cosecant theta is r over y, correct? Cosecant theta is the reciprocal of sin theta, which is defined as y over r, no? Cosecant theta is r over y. Therefore, cosecant theta is square root of 5 over negative 2. Okay. Pero sa multiple choice exam, usually kanang negative sign ako nang ginabalik diri sa tunga. Okay? And you have to be mindful kung kanang negative sign is not placed in the numerator nor in the denominator. You have to be mindful which of the two between the numerator or the denominator is a negative number. Anyway, the value of the number is not changed because the negative sign may be placed anywhere. Pero when you are to solve for a certain value, like for in this case, which is cosecant theta, you have to know whether or not it is x or y, which is a negative number. Okay, I think that is clear enough. Let's have number 3. I'll just rewrite it since ano siya sa taas. Given sin theta. Sin theta is 1/2. Positive 1/2. Theta is in quadrant 2. Okay. Theta is in quadrant 2. For a point to be found in quadrant 2, its x coordinate or abscissa must be negative, while its y coordinate or ordinate must be positive. Again, a point that is found in quadrant 2 has x coordinate or or abscissa which is negative and has y coordinate or ordinate which is positive. X is negative, y is positive. Okay, that's for a point found in quadrant 2. Sin theta is defined as y over r. Sin theta, based on the given, is 1/2. Okay, so it is undisputable that y is really equal to positive 1 and r is equal to 2. Correct? There's no question on that. Since y coordinate or ordinate in quadrant 2 is positive. In this case, positive 1. R is always positive because R is the distance from a point back to the origin. Okay. So what is x? X is the square root of the difference of r squared and y squared. Since x squared plus y squared is equal to r squared. So you have x is positive or negative square root of 3. Okay. 3 is obtained by taking the difference of the numbers 4 and 1. 4 and 1 being the square of 2 and 1 respectively. Between the two values of x, which is positive 3 or negative 3, which will you take? Of course, you will take x is equal to negative square root of 3. Nganong kana mang negative square root of 3, sir? Nganong dili man ang positive square root of 3? It's because the point is found in quadrant 2. Why is the point found in quadrant 2? The point is found in quadrant 2 because that point is a point contained in the terminal site of theta drawn in standard position. And the given states that theta, which is in standard position, is found in quadrant 2. So the x-coordinate or the abscissa in quadrant 2 is negative. So you take x is equal to negative square root of 3. You discard x which is equal to positive square root of 3. Okay. And since you are to find tangent theta whose definition is y over x, so you have 1 over negative square root of 3. Okay. But that is not the final answer because there is a radical sign in the denominator or a radical in the denominator. So what you are going to do is to rationalize the denominator since square root of 3 is an irrational number. It may be a real number but it is an irrational number. So the process is for you to rationalize the denominator by multiplying both numerator and denominator by square root of 3. Or you multiply the entire expression 1 over negative square root of 3 by square root of 3 over square root of 3. Okay, unsa ganito? When you multiply 1 over negative square root of 3, for example, by square root of 3 over square root of 3, are you changing the value of the expression? The answer is no. Since square root of 3 over square root of 3 is equal to 1, and any number multiplied by 1 is equal to the same number. Square root of 3 again over square root of 3 is equal to 1. A number is divided by itself. So the answer is square root of 3 over negative 3. Since you have negative square root of 9, so it's negative 3. So tangent theta is square root of 3 over negative 3. This is the answer. Okay. More.